Okay. Let's see. All right, I'm trying to figure out the light bulb might be the answer. Nope. What presentation? How about, wow, best exam lighting. That would work really well, wouldn't it? How about ceremony? I'm just trying to get like, how's that? Okay, I've got it live streamed for anybody that wants to watch it on live stream here. All right, I'm gonna close that out and let's, that's about as good as I'm gonna get here. Close you, all right. All right, I guess everybody's here for AMP, right? Excellent, okay. All right, well, I'm Dr. Kennedy, and I'm filling in this semester for Dorothy Scholl, who's taking a well-deserved family leave for once. So you guys have me, and I recognize some faces in here already. So it makes me happy to see some bright, smiling faces. Any rate, the university has decided it was going to barrel ahead with face-to-face instruction, regardless of the fact that there are 800,000 cases of COVID a day, of the most contagious virus we've ever had. I have 2 unvaccinated kids at home. Please wear your mask. I'm serious. I'm not playing around with that one. And you know what? Everybody's good. Thank you. I thank you. I was going over my head what I was going to have to do if nobody wore a mask, if somebody didn't wear a mask. So thank you very much for the respect. So I'll give you the same respect. And in fact, so what I've done is if anybody's interested, you do not have to come to class if you do not want to for at least the first month. Because of COVID, some of you may have the same situation I have at home with young unvaccinated kids, immunocompromised. You might not just feel comfortable coming in. I'm going to be frank with you, this is well beyond my comfort zone of how many people I want to be exposed to. Now, that being said, if you feel like you want to come to class, because I love it. I love being in class. And if you like being here and this is what you need, please come to class. If you feel unsafe, if you feel like this is beyond your comfort level, that's okay. It's fine. I will live stream this. I will make probably some better videos for you guys because I'm looking at how this is live streaming and it's not going to be all that great. But you'll at least get my voice over with the lectures, the slides I've already posted, and I'll see if I can do a little better video for you guys. So the point that I'm making is if you want to be at home or somewhere else watching the lecture, you can do that. I will live stream them constantly. Are we good? So every day I'll live stream it and I'll post it on YouTube. I have a Facebook channel, not Facebook, sorry. Sorry, I just did an hour-long lecture just a few minutes ago. I have 3 lectures back to back, and then an hour break, and then another one. Whew. Up until spring break, though. This is my Oh, told you I'm nervous. Good. It's a little crowded in here. This is my YouTube channel. One of the greatest inventions in social media is, of course, YouTube. You can learn a lot on YouTube, like how to change sensors on a diesel. Or you can learn about AMP. Gosh, there's so many resources available to you guys. But this is my YouTube channel. This is where I will be posting the live lectures. You just go here, catch my live stream. It'll be on here. I'm also keeping them in a folder for you. I have a playlist. It'll be AMP1, and you can just go to that playlist. You'll see lecture 1, lecture 2, and any other lectures that you need for this class will be in the playlist that says AMP1. I just made it like this morning, so I'm just doing my first lectures now, but they'll be there. So you can catch the lecture live at home, or you can watch it later. I've also decided all tests will be online almost certainly through spring break. And the test online, open book, open note, 4 days to take it, take your time. I expect you to research the answers. Okay? Good. It's up to you to learn it. Now, how many of you are going into nursing? Yeah, so just as a heads up, you'll learn by taking a take-home test. I promise you, you'll learn. What you won't learn that's going to come back and bite you if you don't study is a skill you're going to miss out on is learning how to memorize and organize information, right? That is a valuable skill of memorizing the parts of the body, memorizing how a muscle contracts, and then writing that down from memory, because that's a lot of information, a lot of moving parts, and that is a very valuable skill. It's like training your brain how to think and how to memorize and how to store information and organize that information. And it's teaching you how to learn something complex. You're going to miss out on that if you don't study, okay? Just saying. And one of the ways you can take those online exams is you can try to answer as many as you can, study ahead of time, answer as many as you can without your notes and your resources, and then go back and then make sure you have it, because you'll have days to answer them. So I always suggest trying to do it ahead of time. Spend some time on it, do it without your notes, and then go back and fill those gaps. Good? Because you'll want that skill because for nursing, you have to take a licensing exam. And if you haven't learned how to study and memorize information, store that information, organize it, and learn something complex, you're going to be doomed, just as a heads up. Okay? All right. I don't want anybody to be doomed. I want you all to be successful. Yeah. Okay, so there's my YouTube channel, and as you can see, I have fun stuff on there. It's not all just about my lectures. I teach a lot of classes from cell and molecular biology this semester. I teach a lot of 303, which is ecology, evolution, 304, plant, animal, form, and function. And some of you may know me from Bio 1140. Anybody have me from Bio 1140? Cool, yeah, I definitely recognize a couple faces in here. And so all those lectures are here. And then I also have fun stuff like, I'm working on a documentary of the Rio Grande. I don't wonder if it'll play with sound. Nope. No sound. Oh, well. I've never really gotten the sound to work here. Okay. Well, at any rate, I went out and took a bunch of drone footage, and this is the headwaters of the Rio Grande River. Wait, it's in the mountains. I had to hike a ways to do this. And there's the headwaters of the Rio Grande. Okay. Fun stuff. Okay, something else that is very popular today, podcasting. How many of you listen to podcasts? Yeah, I have a podcast. It's called Tom Sidecast. You can get it wherever you get your podcast. Seriously, I'm on Apple, Amazon, iHeartRadio. I prefer Spotify because it actually shows the artwork I select with the podcasts are the ones that I made. I don't have a lot of podcasts for AMP because I typically don't teach a lot of AMP. I teach other courses, but I do have this podcast. I might do some podcasts for you guys, especially if you give me some suggestions. Like, hey, I'd love a podcast on this subject in our class, and I'll see what I can do. All right. So, but that's there, and these are also, if you want to listen to them, they're not required. So even if I do a podcast for this class, it's not required. And then Facebook. Oh, Mark Zuckerberg. Bad man. Create this thing to connect the world and everybody's grandmother. I know you guys probably are not on this at all. It's like, it's for old people, right? When I was in college, or graduate school, this was cutting edge stuff, right? Poor MySpace. Man. Well, at any rate, I do have Tom Kinney Science on Facebook. It's not required, but I often will post stuff on here that is relevant to class in terms of stuff we're talking about. I'm really into diet and exercise. I've been studying that a bit and learned a lot here recently. I've had my paradigms overturned about the role of exercise on weight loss. And I dug my heels in for 2 decades. I was wrong. Well, sort of wrong. And then I hiked 100 miles a month and lost 15 pounds. But I'd wake up every morning and go for 5-7 mile hikes just to see that you could do it. But that was a lot of hiking. So at any rate, on Tom Kinney Science, I do post fun stuff on here. So The one thing that you'll want to go to, though, for the lectures material will be here. Okay? So if you decide not to come to class, you can go here to get your material. Good? So I'm giving you a choice of whether or not you want to come to class. And then as the pandemic subsides, it's already starting to go down. Yesterday was 802,000 cases. Today it was 798,000. It's dropping for the first time since before Christmas. All right. I knew this was going to happen. It's going to flame out quickly. But until it flames out, like I said, if you don't feel safe being here, you can watch these on Tom Kennedy Science. Okay. Any questions? All right. That's the fun stuff here. Okay. I look out. I don't have to make any comments about face masks. We got them all, right? Wear these N90s or N90, what are they? N95s or something. Don't wear the cloth ones. The viral particles are tiny. Cloth is big. It's like wearing a cloth mask and trying to stop Omicron or COVID is like trying to stop sand with a fence, right? It's going to flow right through it because the pore spaces in your cloth mask are way bigger than the pore spaces, or way bigger than the virus particles. Okay, let's see. So here's the syllabus. There's all this stuff on there about indoors. Let's not sit too close to each other. Yeah, that's going to happen in a crowded spot. Okay. Let's see here. Everybody got access to the book. Yeah, you get it when you register for class. You don't have to go buy anything extra. When you register for AMP, you automatically get access to the AMP book, and it's through Red Shelf. So you guys are familiar with Learn, I take it, right? I mean, you guys have been through this before. So it's all on Learn. The Red Shelf materials are there. And then I'll post all of my material by week. So you'll have week 1 through week 16. Good. So if there's any material that's on a YouTube channel, if I post a podcast, homework assignments, I'll get through there. Well, actually, homework assignments are through Mastering. We're still trying to get my UNM Learn linked up with Mastering. It's never as easy as you think it is. Okay. So in this class, it's a 16-week class. And 16 divided by 4, that's hard math right now, isn't it? 4, right? We have 4 tests. You can expect the first 2 will be online. I can't imagine why I would do the second one before spring break in class. And the reason why I'm doing that is so you don't have to come to class to get credit, okay? I'm giving you a choice. I seriously am. Like I said, I don't want anybody here that feels uncomfortable. But I do know that being in class is great. I'm so happy to be here, despite my comfort levels not being comfortable. Okay, so what we're going to talk about this semester is histology. You guys know what that is, right? The study of tissues and cells. Kind of interesting stuff. You know, we have like 4 major tissue layers, but we've got like 200 different types of cells. They're all genetically identical for the most part, and they're all doing different things. And so histology is the study of our cells and our tissue. So it's at like the most basic level here. Not one step up from organelles so much. Then we're going to study 3 main systems: bones and connective tissue, which is kind of cool, bones and ligaments. And as you get older, you will curse your ligaments and tendons because they don't repair so fast. They wear out. I think every articulating joint on my body hurts sometimes. Well, when you power lift for 20 years, play competitive racquetball and hike all the time, you wear your body out. So bone tissue, and then we're going to talk about muscle tissue. Like I said, I competitively powerlifted for a long time. So for me, studying like how muscles work is incredibly fascinating. And we're going to get into the nuts and bolts of how that works, of how muscles work. I mean, and it's just fascinating stuff. And when I learned biology, even just 30 in the 90s, right? Yeah, we've come a long way in our knowledge about how muscles work. And then the other thing we're going to talk about is the nervous system. And the nervous system, I mean, our brain is the most complex structure in the known universe, right? I mean, it's an amazing thing. And we're going to learn parts about our parasympathetic and sympathetic nervous system, fight or flight, or eating a donut and relaxing in front of TV, right? You ever watch the movie Predator? Get to the Chapo? There's even a music band called Austrian Death Machine, and the guy sings metal, heavy metal, like he's Arnold Schwarzenegger, and he has songs like Get to the Choppa and One More Rap. If anybody likes that kind of music. In my family, we all listen to Leo from Frog Leap Studios. He turns every song into a metal song, like Baby Shark. There's a metal version of it out there. It's awesome. Okay, so there we have it. Histology, bones, muscles, nervous system. We're going to learn how a nerve contracts. We're going to learn about our nervous system. Good? Fun stuff, huh? Yeah, all right. And then, of course, we've got the 4 tests. They're 100 points a pop, and then there's 4 of them every 4 weeks. And then, like I said, the first 2 will be online for certain. I'll reevaluate after spring break. We'll keep with the online or in person. Like I said, for most of you going into nursing, it'd be better to get back to in person so that you can learn how to study. I mean, it's a skill you need. So when we learn complex things, you're probably thinking, why in the world do I ever need to learn how a muscle contracts at this level? You might not ever see it again. Some of you just might find it fascinating. Some of you might decide to go into exercise physiology and study this for a profession. But one of the other things we're doing is we're teaching you a skill of how to, like I said, master memorization and organization. Okay. Yeah, this is all the stuff about support services and everything here. It's all there. And the schedule is tentative. I'll try to keep on track. The test I'll post on Thursday. They'll be due on Sunday for the first 2 tests, which will the first one be in 4 weeks. And then the next one will be right before spring break. And like I said, I'll reevaluate at spring break. We're still having 500,000 cases a month. No way. It'll be online. We'll stay online. Thinking like a 5% positivity rate. You guys need choices. Okay. Any questions here? All right. Now, let's do this. We're going to go into not that lecture. How about how to learn? Some of you have heard this. If you've had me before, I've heard this one. Now, before I get started, let me ask you guys a question. How many of you have a hard time listening to somebody chew gum? Yeah, do you hate mouth noises and watching people eat? And it's hard, isn't it? I have it too. It's called misophonia. Miso means hatred of sound. And we have these unreasonable responses to a normal sound, like somebody popping gum, like literally sense pain throughout my body, right? So people with misophonia have a very difficult time being in a quiet room with somebody making noises, like chewing gum, eating something. And that's me. And another one that's very distracting is typing on a keypad. Very distracting. So I see lots of computers out today. You might not even have brought pencil and paper. It's okay today, but from now on, let's take notes with pencil or a pen. And there's several reasons, well, there's 2 reasons why. One is if you're striking on a keypad, you're not only affecting me, and like I said, I'm already beyond my comfort zone. That's going to distract me even more. I'm going to keep calling Facebook, YouTube. But if you have pencil and paper, great. If you don't have pencil and paper, no worries. You can keep typing today. I don't want to take away your ability to do notes. And then the other one is, this is a more pedagogical reason. You learn better when you write, actually, over typing. It's a weird thing. You would think that typing, you would retain the same amount of information, but numerous studies have actually shown that writing lecture notes or writing notes down is a much better way of retaining information. So it's not only helping me out, your fellow classmates out that have a hard time listening to people strike on a keypad, but it's also helping you out because you'll learn better that way. So from after today, let's not have any laptops in class, okay? All right, I appreciate it, and so do other people around you, and you will too. Okay, any questions before we get started? None? All right. Have you guys ever thought about how to learn? How we learn? Sit down with a book, read it over and over, thumb through your notes, read it over and over, make flashcards. Sound familiar? Yeah, that's how I used to learn too. Get in study groups. You learn very well in study groups. The reason why I want to talk about how we learn is because an A&P is very hard. And I think, this is it's a tough class. I mean, there's a lot to learn, a lot to memorize. With the first two tests, you won't be memorizing as much, but there's just a lot to know and a lot to organize. And there's some complex things we're going to learn, like how a nerve cell sends a signal down an axon, right? Like, it gets even more complicated than that when we start talking about the nervous system. But there's just a lot. And so this class requires a lot of time from you studying. I mean, we often say between 6 and 10 hours a week. Are you going, wow, that's a lot? No? Yeah. I mean, how many of you have played a sport before, done sports? I mean, yeah. How often do you practice your sport? Oh yeah, when I've been weightlifting since 1989, right? 4 times a week. When I was an undergraduate, I didn't miss a day, man. I was in there 6 days a week. I was overtraining, didn't know it, but But with sports, you train consistently, right? You can't stop, because what happens when you stop? Well, you stop progressing, you regress, you get out of shape. Learning is a lot like doing sports. You have to stay at it, you have to stay on top of it. And the more you learn, the easier it actually gets. It's like, I can't run at all, but you ever tried to like run after sitting on the sofa for months playing, like, I don't play video games, but binge watching Star Trek on Netflix or something? You could try to run a mile. It's kind of hard, isn't it? You gotta practice. You gotta warm up to it. You gotta start a little bit at a time. Run 100 yards and run 200 yards and walk. Learning is very similar to exercise and getting your body in shape. As your body gets in shape, it makes all of these changes that allow you to be able to run faster, run longer, or lift more weight, lift more reps, right? In fact, that's a great song called One More Rep. So A&P is hard, right? We're all trying to run a marathon here. You can't just get up and go do it. It takes self-discipline, motivated. You gotta study hard. Now, one thing that I've said here, when I was an undergraduate, when I was a freshman in college 30 years ago, I worked out 6 days a week for 2 hours. Is that overdoing it? Probably. So one of the things that I want to talk about is being effective in our study. It's not just sitting down with the book for hours and hours and hours and hours and expecting success. It's also, like training, you can overdo it, you can train ineffectively, you can also study ineffectively as well. Does that make sense? Okay. So, but to do well in this class, you need these traits. And don't get behind. I mean, I know that you're probably breathing a great sigh of relief to have an online test. I know I would be. I would have loved that in college. But let's not get behind. Really try to stay on it. I mean, if you wait to the last minute to take your test, you're going to be struggling, because I'm going to write questions that you just can't easily Google the answer to. Okay? I'm going to be straight with you. And I'll give you examples of what I'm looking for. So if you need help, ask for it. I'll have Zoom drop-in hours for my office. I'm in room 73. Okay. So I talked about what we're going to cover this semester. In learning, there are different levels of learning. one of the most common things I hear is, I understand the material, but I didn't do well on your test. And I'm sure you've had other teachers say that. You can pull it up over your nose if you would. The virus lives inside of our nose, right? That's why it's so contagious, because it's just shedding right there. That's why it's so important to keep it over your nose. How many of you said, I've understood the material, but I didn't do well on the test, and I don't know why I didn't do well? It's happened to me. I mean, honestly, I've taken tests. What's going on here? There's a difference between understanding and memorization. But learning begins with building up what is called our foundational knowledge. This is memorizing, right? So if you want to memorize how a muscle contracts, you have to start memorizing things like actin, myosin, ATP, calcium, right? You've got to start memorizing all these parts. You've got to memorize where they're at. So learning begins with building our foundational knowledge. That's memorizing. So how many of you use flashcards? Great. What kind of, are you doing this right here? Yeah. So it's a good way to start learning. Absolutely. We build up our foundational knowledge. Anybody know what that might be? What cellular organelle? Mitochondria, my favorite organelle. I know. The mitochondria is my favorite organelle. And we can memorize very easily. What does the mitochondria do? Makes ATP. It's the powerhouse of the cell. Now, a couple of you that have heard me before, been around me, know that the mitochondria is way more than just the powerhouse of the cell. I mean, this thing's responsible for programmed cell death. Did you know your cells kill themselves? By the billions every day, you lose cells through a process called apoptosis. You thank the mitochondria for that. We have sexual reproduction. We have two sexes, male and female. You could thank the mitochondria for that. We would not exist if it weren't for this organelle right here. Isn't that amazing? It's responsible in part for aging. Sometimes responsible for infertility. Yeah. You ever notice, like, kids? I got a 4-year-old. Man, it's like a little berserker. Little boys are even worse. Oh my gosh. They go to the playground and little boys just have like so much energy. My daughter has energy too. Grandparents. What do grandparents do? They sit in a chair and watch the kids, right? Because they don't have as much energy. They have too many old mitochondria, not making enough ATP. So mitochondria is way more, but we can easily memorize that the mitochondria are the powerhouse of the cell and make ATP. That would be foundational knowledge. You just memorize it. Now the next step in is do you understand why they're the powerhouse of the cell? You can say, well, they make ATP, but what's the importance of ATP? You guys remember ATP? You can memorize this. What is it? Adenosine triphosphate. What is ATP? Why is it important? Energy currency of life, right? Every living organism on this planet makes ATP, right? And the vast majority of ATP is made through a process called chemiosmosis. So as we start to understand why the mitochondria are the powerhouse of the cell, we start understanding things like, remember that whole citric acid cycle, Krebs cycle, cellular respiration? You learned it, probably forgot most of it, that's okay. It happens. But there's a whole process to make this molecule right here. And then do you know why ATP stores so much energy? Well, what's a phosphate group made of? I'll just put an A for the A part. Let's look at some understanding here. phosphate. What's that bond right there? It's a chemical bond. Do you remember what it's called? Sharing electrons. It's a covalent bond. This is an oxygen. It's missing a hydrogen, so it's got a negative charge, negative charge, negative charge. What do negative charges do? They attract or repel each other. Oh, come on, guys, help me out here.
Repel each other.
Of course, same charges repel each other. So all these oxygens have slight negative charges because oxygen either has lost its proton or it's way more electronegative, which means it loves electrons. Oxygen loves electrons, but it's pulling them away from this phosphorus here. These all have partial negative charges. This whole thing is like negatively charged. You ever taken a rubber band and stretched it? I don't have one up here, but if I took a rubber band and stretched it this far, would you care? If I stretched it this far and I aimed it at you, would you care? You'd be like, don't shoot that thing at me. The reason why is when you stretch it a long ways, it has lots of stored energy, lots of potential energy. And when you let it go, that energy is transformed into kinetic energy. And if it's going faster, it hurts more, right? Yeah, exactly. Okay, so understanding. I can recite that mitochondria are the powerhouse of the cell that make ATP the energy currency of life, but that next level of understanding is like, hey, I know what ATP looks like. I know that with all these phosphate groups on here, that bond has a lot of potential energy in it because it's being stretched like a rubber band, and it's easily broken. And so it's easily broken, doesn't take a lot of energy to break it, and it forms a new bond, a lot of energy is released. See what we're talking about with understanding here? That's the difference between memorization and understanding here. So, okay, foundational knowledge and memorization. Understanding is a second level of learning, understanding what things actually are. Another level is application. Can you apply what you've learned? Here's an example. Eukaryotic cells. You guys remember eukaryotes and prokaryotes, right? Eukaryotes are like the bacteria in your teeth. Yeah, that's prokaryotic cells. They don't have a nucleus. Eukaryotes do. All eukaryotic cells have, or at least had, a mitochondria. And in fact, that's the actual real evolutionary definition of eukaryotes is they have mitochondria, or at least they used to. All eukaryotes have mitochondria. All eukaryotes use oxygen to break down carbohydrates and make ATP. You got that, right? Okay. This is a spider lily, a really beautiful flower from North Florida. Plants are eukaryotic cells. The plants use oxygen.
Yes.
They do. They're inspired. Wait, did I just blow your mind? Getting a lot of looks like, what are you talking about, man? Yeah, plants are eukaryotic cells. Do they have mitochondria? They do. Are they doing aerobic respiration? Are they using oxygen to break down carbohydrates to make ATP? They are, except not very much because they don't have a very active lifestyle. You know, your muscle cells, any of you here runners, cyclists? A couple of you? You guys have a lot of mitochondria, thousands of mitochondria in your muscle cells. Not the 3 or 4 you see in the textbook examples. Your cells have anywhere between hundreds to thousands of mitochondria in them because animals are large, complex, very active organisms. A plant, well, that's on my chest. I haven't seen plants get up and move around very much. That'd be pretty terrifying, right? You see a carnivorous plant come out and grab somebody. So because they're not as active, they don't have as many mitochondria, and they do photosynthesis where they use oxygen to fix the carbon into carbohydrates. Okay. And then there's a plant cell showing, of course, the chloroplast in there. So there are other levels of learning. It's called Bloom's Taxonomy, if anybody's interested. I think it's in your book, where you've got foundational knowledge, then you've got understanding, application, and then can you evaluate information? Like, that's very important in today's world, because some people are not evaluating the information on things like messenger RNA vaccines, that they're safe and effective and they actually work. I've had people tell me that they don't work. I've had people tell me they're not safe. I've had people tell me it's just so these companies can make money. They're not evaluating the information correctly. So foundational knowledge, understanding, application, evaluation, and what might be the highest level of learning?
Creating our own research.
Exactly, creativity. Creativity is at the top, because it's hard to be creative if you don't know and understand anything. If you know stuff, you can apply it. Okay. Now, how many of you in here think you are expert or novice learners? Do you know the difference? How many of you might think you're a novice learner? I doubt that. How many of you think you're an expert learner? How many of you have no idea? Hey, fair enough. Absolutely. Fair enough. Okay. Years ago, I was living right over there, and there's apartments over there off of Lomas, and Indian school, and I forget where they are. Anyways, I walked up one day, and there's like a robin building her nest, and there's like these little baby robins. So like right outside our stairways was this nest. I was able to take these nice photos here. Didn't have to do anything special. These baby birds are going, cheep, 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 feed me, feed me, feed me. They're what we call altricial. Human babies are born altricial. They are completely dependent on their parents for all types of food, nourishment, and protection. They cannot take care of themselves. They are given everything they need. Does that make sense? A novice learner is much like these baby birds. And we all start out learning this way. I mean, we're not born expert learners. We all start out learning, right? The basics of learning. A novice learner is the type of student that says, just tell me what I need to know for the test so I can regurgitate whatever definition you give me, or label whatever cell diagram or muscle diagram, and I can just repeat that back to you. Tell me what I need to know. And then the teacher just recites, this is the humerus. I find this humerus. Okay. And then you go and you find it, you label, that's the humerus, that's the radius, ulna, bicep, tricep, right? And you just label these things back because I told you that's exactly what you need to know. And that's a novice learner. And a novice learner really doesn't know how to learn much more than memorization. They don't really know how to learn. They can sit there and just brute force, get spoon-fed a bunch of definitions, a few diagrams, and just repeat it back. They don't really know how to do much else. That makes sense? Okay. There's expert learners. Yeah, I was on the Masai Mara, which is the upper part of the Serengeti, one year. And there were these 3 cheetahs. And they were sitting there acting like house cats. Pretty amazing watching like an 80-pound cheetah look just like a house cat and act just like a house cat. The next thing you know, these cheetahs spread out in a 3-prong attack. And this Thompson's gazelle comes up over the hill. And this cheetah took off after it, 65 miles an hour. And the other 2 were herding it into one place. The outcome of what was going to happen was apparent within a few seconds. And I actually had a nice telephoto lens, was able to get up on this cheetah and get some photos of it eating its dinner. Expert learner. This cheetah knew what to do. It knew how to go find the food. It knew how to they knew how to work together to go catch this Thompson's gazelle. An expert learner is somebody who knows how to learn. And one of the big difference between a novice learner, where you're just memorizing a bunch of terms, foundational knowledge, and an expert learner is you have self-awareness, metacognition. You're aware of what you don't know. So when somebody goes, I'm a novice learner, and I know that they're really smart, they're underestimating their abilities, so they often will work hard and do very well. Expert learners, you ask an expert learner what they made on a test, they'll often underestimate how well they do. Oh man, I missed X, Y, and Z. I missed X, Y, and Z. You know, if only I'd written this other sentence, because they're aware of what they didn't know or what they messed up. A novice learner comes out of a test and goes, yeah, I passed it. I get a 50. What the hell just happened, man? I don't understand. Expert learners know how to learn. They are aware of what they don't know. They also know how to learn something complex. So how many of you learned to I'm gonna bring it up from your past, don't cringe, oxidative phosphorylation? Did you guys learn that in 1140? How many of you had it with me online? A couple of you. Then the rest of you had it with Cameron, right? Dr. Buckles? You guys did cellular respiration in there, right? Yeah, sure, absolutely. So did you find it hard to learn oxidative phosphorylation, all the different parts of chemiosmosis, the electron transport chain, and all of that? Probably not. I mean, but for some of you, was it hard? Really? Man, when I first was introduced to the cellular respiration of glycolysis, pyruvate oxidation, citric acid cycle, and oxidative phosphorylation, all the 4 stages of cellular respiration in biology, I was so lost. I was like, what the hell did I just learn? I was so lost. And I had to sit down with a book, and I was trying to figure out all these different steps. And I had to learn it in steps. Look at the overall process, like a muscle contraction. Okay, what has to happen, right? Or a nerve conductance. Well, I've got to have an action potential. Well, how do I trip the action potential? How does that signal travel down the axon? Oh, it's sodium-potassium channels and sodium ions getting in there and being pumped out, moving around. You get where I'm going, right? Have I lost you guys completely? Okay. The point is that I'm trying to make is an expert learner can take a complex problem that they've never seen before, and they know how to learn it. You know how to learn something like cellular respiration. If you can commit cellular respiration to memory and understand how it works, then you trained your brain how to learn something complex, and guess what you can do next? Now you can take that skill of learning something complex, now you can learn how a nerve cell sends a signal down the axon. Good? Or you can learn how a muscle cell contracts using the sliding filament theory. Your muscle cells contract like this. They just slide, the filaments slide past each other, and you get a contraction. Good? Okay. You know how to learn. One of the hardest things is being self-aware and not realizing that you don't know stuff. Oops. I love this picture of this 1960s family watching South Park. Anybody still watch South Park? I love that show. Those guys are so brilliant. I've been watching them basically my entire adult life. They started out in 1997. I had just graduated college. I took 5 years in college. And they started the year I got out. I have not missed a season since, and the last episodes were hard. They were so good. Greatest show ever. How many of you love to watch Netflix and binge watch Netflix? Oh yeah. I mean, I don't care if it's Netflix. I mean, how many of you have binge watched a show before, right? Yeah. What are you guys binging right now?
The Witcher.
Yeah, is that good?
It's pretty good.
No, it's good to know. Yeah, I need to get back into that. There's also Wheel of Time, but anybody else?
You.
Which one?
You.
You? I am not familiar with that. Tell me.
You need to watch it. It's about, you're literally rooting for the killer.
Oh my gosh. Yeah. See, on my Facebook post, I said, first time back in class, I can't wait to see what I'm going to learn today from my students. I already learned a show I need to watch. Anybody else? What are you guys watching these days? Oh, I like that one. In the back, yeah. That's a good one. One of my friends, that's his favorite show. Yeah. That's a good one. Anybody else want to share what you're watching? I mean, this is how I learn too, right? It's kind of fun to talk about this stuff. Yeah, I'm finally binging Big Bang. I know, I'm behind the times. I'm up on The Mandalorian and Book of Boba Fett though. And The Expanse. Okay, so you binge watched a show. I don't know about you, but I one time I binge watched a show, and I watched like 8 seasons of it, 20 episodes a season. I could barely tell you the names of the characters. And in fact, I had to think about the names of those characters on Big Bang Theory, other than like Sheldon and Wallowitz and Penny and Amy Farrah Fowler. I can't remember his roommate's name right now. Where am I going with this? Am I just randomly talking about TV, or where am I going here? I binge watched this show, 6 seasons of it, couple 3, 4 or more episodes a night, and I can barely recite the names of the characters. Where am I going with this? What's my lesson here?
Because you're just going through the motions.
I'm sitting down and watching it, right? Am I enjoying it? Absolutely. Can I tell you about any specific episode? I might be able to recall a few scenes. I mean, not that I have the best memory in the world or anything. I clearly do not have good memory. My memory is like an iceberg with penguins on it, right? And my iceberg is a very small iceberg with a lot of penguins. So every time I form a new memory, another penguin gets bumped off. I lose a memory, right? And I find out that, fortunately, like, forgetting is actually your brain's way of learning. I should have told you guys that. But I think that's why after a class, and we know that people memory dump after classes at the end of the semester, because you got to make room for more stuff. But you never know what you're going to remember. I remember Wallowitz was an astronomer. I mean, not an astronomer. He went into space. He went on. There we go. The idea of binge watching Netflix is passive learning. I can barely tell you the name of the characters in a show I've watched 6 seasons of with 20 episodes a season. It's like I've watched almost 200 episodes, 180 episodes, right? And I'm having a hard time recalling their names because I am passively watching it. Passive learning, which is kind of what you're doing right now if you're just listening to me, is not terrible, but you retain not very much. If you are in here and you're taking notes, then you're actually doing a little bit more active learning. But just listening to a lecture is similar to watching a TV is passive learning, and we don't learn as much by passive learning. I'm not saying it's useless, because you do retain things. What are some other examples of passive learning? Wish I could play crickets right now. How many of you just read and highlight your textbook? Yeah. That'd be passive learning. Thumbing through your notes, reading over your notes, reading through your textbook. Those are other forms of passive learning. You will learn, and sometimes you'll pick up on something really interesting, and you'll remember it and maybe explore that further. But passive learning is like just listening to a YouTube video, listening to a lecture. It's not a waste of time. It's just not as effective, especially if you're just reading your notes over and over and over. You're memorizing and becoming familiar with your notes, but you might not be building any understanding, or you might not be able to do any application or anything like that. That kid looks determined, doesn't he? Don't mess with the plug socket. It will hurt you. Don't mess with the plug socket. It'll hurt you. Okay, yeah, sure, whatever, Mom. Don't mess with the plug socket. You think that kid's gonna forget this lesson he's about to get? He's doing something. He's actively learning. He's about to actively learn a bad lesson. I love this. Those boys. I have 2 daughters. I don't know how she do with 2 little boys. Yeah, that's the kind of stuff I would do. He's not going to forget that lesson, is he? So the idea when you're trying to learn A and P, passive learning is fine. You know, it's great coming to class. Take some notes. It's great reading the chapter before you come to class. That's great too. Highlight a few key passages so you don't forget them. There's nothing wrong with that. But if that's all you do, and you keep doing that over and over and over and over again, you're like, I studied a lot, but I didn't do well. And that's because you're passively learning. We learn by doing, active learning. What are some good examples of active learning?
Take notes on the textbook or something like that.
Yeah, that's a good one. Take notes from the textbook. Here's a really good technique for you guys. What are you doing after class? Lunch. I got another lecture to go on. I'm going to get through it. My throat's already hurting. There's no soda machines out there. They took them all away. Diet Pepsi.
Wow.
He remembers me from another class where I explained about anecdotal data that because I drink a Diet Pepsi every day, I never caught the cold. So Diet Pepsi must prevent colds. Yeah, it's the aspartame in it, right? It's it's medicinal. It's kind of like an episode of South Park, medicinal for our chicken. That is not a kid-friendly episode, by the way. Do not watch that with your parents or your small children. And they learned by doing in that episode. But we learn by doing. So examples of what you're going to do after a class is one thing that's really effective is sit down after this class, write down everything you can remember. It is one of the most effective ways of learning because what you're doing is several things. As you passively learn, you forget it. I bet if I sat down after the Big Bang Theory, after each episode, and wrote down whatever happened after each episode, I would remember them. If you go and write down what's in class afterwards, you're taking memories that are short-term memories, and you help transform them to more long-term memories. All right, which is good for your test. Secondly, you start to become aware of what you don't remember. I don't remember what that myosin head does. What's a troponin? What's the role of calcium in triple myosin? I don't remember, right? Then, if you don't remember, because now you're becoming aware of what you don't know, right? We're kind of weaving the story together. We become aware of what we don't know. Then you can go look it up and fill in those gaps. And now you've helped create a long-term memory, and you've started to realize what you don't know. This is how you start to become an expert learner. Good? How many of you like to study in groups? Study groups are fantastic. I mean, it's part of the college experience, right? Forming study groups, studying together, and teaching each other the material. So if you don't understand something and somebody teaches it to you, you go and teach it back to your group, and you hope that the group will make sure you get it right. That's active learning. The reason why you're professors, we can get up here and talk on and on and on about all of these things that you guys are like. I remember I was so impressed being in college, and I'm like, oh my gosh, how did that guy like do the entire Krebs cycle from memory? I've done it from memory because we do it every semester. I look at it every semester, and then I teach it to you guys, and I'm forced to memorize it and regurgitate and throw it up here. And now, like, I haven't taught it in a classroom in almost 2 years. I can still walk up and do the entire, as I'm thinking about it, can I? Yes, I could. The entire cellular respiration. I'm forgetting that I forget a couple things of the glycolysis. They don't often teach like every step of glycolysis. I mean, I can remember where the major ones are. And why can I do that? Because I'm much smarter than you guys are. It's just I do it all the time, and I teach it, and I study it, so you guys can do that too. Teach each other. Good? Is this helpful? I hope. Good. Your book has some stuff on this too, and I feel like in a class that's really hard, it's good to talk about the meaning of learning so that we're all on the same page. And of course, this is like the cone of learning. If you read about 10% words you're seeing. You know, I mean, it does vary for different people, but the main point is that you learn less by passive learning, you learn more by active learning. Good? Okay. And of course, have self-awareness. This is that metacognition. This is being aware of what you don't know. And that's hard. There's no doubt about that. It's hard to know what you don't know. That's why the exercise of writing down what you learned in this lecture today. You didn't learn a whole lot today. But in the future, if you do this, it will help you become aware very quickly of what you don't know. And like I said, one of the most common things I get is, I understood the material, but I failed your test, or I didn't do well in your test. And it's hard when I say, you didn't understand it, that's the problem. I've actually had students call me out on that, like, you just said I don't understand it. And I'm like, you don't, you've memorized some words with no understanding. We want to get beyond that. In this class, we've got a lot of foundational knowledge to learn, but we also have a lot to apply it to, okay? All right, any questions? No? Okay. I think I've still got, what, 15 minutes? All right. Let's go on here. I'm just gonna go through this very quickly. Let's shift gears. And I'm not gonna spend nearly as much time as I did on this in my previous classes, but I feel like I always like to start from the beginnings, right? So even though we're talking about anatomy and physiology, this is a class about life. And for those of you that don't know me, I love astronomy, I love biology, astrobiology, I love evolution, natural history. I really like thinking about, what is life, our connections to the earth, our connections to the universe, our connections to stars. It's kind of fun. And right now we're in this golden age of exploration where we're going out and we're looking for life on different planets and moons. It's quite fascinating. And I always like to ask the question, if we were to find life somewhere else, would we recognize it? What do you guys think? Well, every textbook, I'm teaching from 2 different textbooks in this semester, and I wrote my own class because textbooks they're good knowledge. They're good encyclopedic knowledge. They're like the Wikipedia. They're about as accurate as each other. You guys got that right. Did you hear what I said? Your textbook's about as accurate as the Wikipedia. How accurate do you think your textbook is?
Pretty accurate.
Yeah, absolutely. Oh yeah, it's been written by experts in the field. It's been vetted by editors and other faculty members. Wikipedia is about as accurate. Use it. But could you get a degree in college if you just read a bunch of textbooks? No. We like to think things a little bit differently. So this is what our textbook says. This is actually different from the textbook I used just a few minutes ago before I came to this class. And it says characteristics of living organisms. Life is made up of cells, there's metabolism, there's growth, there's excretion, there's responsiveness or irritability. I guess I wrote that in the morning. Didn't get their caffeine. My caffeine, of course, is Diet Pepsi. Movement, and they must have kids, and reproduction, right? Man, how's that different? Oh yeah, there's no evolution. Yeah, these are completely different from the other one. The other one had like evolution on there, energy. No 2 textbooks, and they're set from the same publisher. They're coming up with very different things. But does that feel a little lacking to you? We're going to talk about something that's living. We're going to describe life, the characteristics of living organisms. What do you guys think about this list? Can we do better, you think? Oh yeah, here's the other textbook. This is the majors textbook. This is the one we use for the core biology. That's what another textbook says. There's a little blue heron from North Florida sitting on a cypress tree surrounded by Spanish moss. Spanish moss is related to pineapple, and here's rocks from Tent Rock. I can use characteristics to describe both of them, but one of these is living and one is not living. What's fundamentally different between that little blue heron, which represents life, and those rocks? Yeah. What's that?
Cells.
Absolutely. Yeah, cells. And cells are really important because they're the basic unit of life, right? So what makes a cell different than a molecule? Yeah.
Cells maintain homeostasis.
They do maintain homeostasis. Maintain. That's an action, isn't it? Living. If you're living, are you doing something? I mean, even if you're binge watching Big Bang Theory it's not on Netflix, it's actually on HBO Max. How many live streams do we have to have? But the point is living. Could there be more? How about this? What do you guys think about that? Life is an action. Life is a verb. Life does something, right? This is a type of coral related to sea anemones, but it's not a sea anemone. So no, you wouldn't find Nemo swimming around in that. I can't help myself. You guys watch Finding Nemo? They're clownfish, right? They're made after real sea creatures. Clownfish are proto-androus. Proto means first, andry means man. Marlin's dad, and he had a mom, right? What happened to Nemo's mom? She died. In clownfish world, Marlin would have changed sex to become a female. I guess you'd call her Marlena. I can't help myself sometimes. Sorry. Disney killing off parents and getting the biology wrong. No, seriously, Disney hates parents. Right? Lion King, Bambi. And then this is a snowy egret. And these are all living things, right? So the question is, what are they doing? What makes them unique so that they're alive, right? How are they different from a rock, which is not alive? Now, I'm not here to diss rocks at all, because when you pick up a rock, you go hiking in the Sandias, you pick up a piece of granite from the mountain, that rock is 1.4 billion years old. It's got a long history, right? Okay, what do you guys think about this? Life uses energy to create order. You are an ordered system. You are organized. You might not think you're organized, but the air around you is completely disorganized. The air particles are moving around in completely different directions. It's completely chaotic. You are not completely chaotic. You're organized. And have you ever cleaned your house? It takes work, doesn't it? You got to spend energy to go wash all your dishes, stack them, stack your pizza boxes. So you got your Supreme on the bottom, pepperoni on top, right? You guys don't stack your pizza boxes in here. That's just me. But anyway, you get the point here, right? You're organizing your kitchen, you're organizing your clothes. To create that order requires you to do work, and that requires energy. So life uses energy from this environment to create order. Life is doing something. We're creating order. So energy flows through your life. Like the Force flows through a Jedi. It's kind of fun to think about that, but energy absolutely flows through life. without energy, there is no life. And how come we can't recycle energy? Anybody ever heard of the laws of thermodynamics? Yeah, right. You got the first law, the second law. There's actually a zeroth and a fourth law too, but we know that energy can't be created or destroyed. Yay! But every time you use energy, it becomes degraded. That little pesky thing called entropy increases. So with energy use, the available energy that you use to do work, like organize your bathroom, as you use energy, that energy becomes less and less available. So life cannot recycle energy. You have to have a constant supply of energy flowing through you so that you can maintain homeostasis, do work, create order. Oh, now you go microwave or go throw your pizza in the oven. Are you adding energy to your pizza? Are you adding energy to it? Of course you are. You're heating it up, right? That's kinetic energy. Temperature is a measure of the thermal energy, right? It's kinetic. So you can microwave a jar of peanut butter, makes it a little bit easier to scoop out. You can microwave a pizza, put your pizza in the oven, you're adding energy to it, but that doesn't mean you're making it more ordered, because life can't use just heat so well. What life does is it requires energy to create order, but it does that through metabolic reactions. And remember, metabolism is the sum of all your chemical reactions. You eat a pizza, catabolic. You break down the carbohydrates into simple carbs and their building blocks. You break proteins down into amino acids. You break lipids down into, well, whatever you break lipids down into, ultimately carbon dioxide and water, right? Those molecules have energy that's stored in them. And through the process of cellular respiration, you transfer that energy in the foods we eat to which molecule? Energy currency of life? ATP, right? So we're constantly using these metabolic reactions to transfer the energy we get from our environment to ATP. Plants that do photosynthesis, guess what? Before they make any carbohydrate, they actually convert the kinetic energy in sunlight first to ATP. They do that, and then they use ATP to help fix carbon. So then once you've got all your building blocks, like amino acids, which are building blocks for proteins, you break them down, then you build them back up. I've got one Lego ship over here. I break down all the Legos into their parts, into my building blocks, and then I go make the Lego Millennium Falcon, and the world is great. I've been wanting the Lego Millennium Falcon for years, right? But there's polymers, right? Polymers and monomers. So it's not just you're taking this random energy in. Life emerges from chemical reactions, right? And those chemical reactions are used to help process that energy and create order. Now, of course, chemical reactions are not random. All life has information stored in its DNA. You good with that? So that DNA stores all the information to make proteins, regulate when you make those proteins, how much protein you make, and when not to make proteins. So not only are we storing information to make proteins, but we also store information to regulate the activities of the cells. And then you copy that information. If life didn't reproduce, it would quickly arise and die out, arise and die out, arise and die out. It would form some metabolically active rock in the bottom of the ocean. You know, weird metabolically active rock. It's a rock with a bunch of complex chemistry in it. It'll disappear. But if you can take that information and copy it, make a new organism, a new generation, then life, you can ensure the continuity of life. And this, of course, is the horseshoe crabs. They're really amazing animals. They have been coming up on shore for 450 million years. 450 million years. Laying their eggs in the springtime on high tide, like they've done for long before the dinosaurs ever. Before there were even animals on land, horseshoe crabs were laying their eggs at the edge of the beach. Pretty cool. So that's reproduction. We're going to copy that genetic information into the new generation. That ensures the continuity of life. Now here's what's cool about this. Life arose on Earth about 4 billion years ago. And you represent the end product, the end result of 4 billion years of evolution. You represent an unbroken lineage of life going back to the very first cells. Your great, 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 how many greats? Like several billions of greats, right? Ancestors were bacteria living in the ocean billions of years ago. Now, how many of you have ever copied information and copied it wrong? Oh man, I do it all the time, right? Yeah, well, life does the same thing. It's called mutations. Mutations create variation in a population. So things like light skin, blue hair, blonde hair, blue eyes. My daughters, they are mutants because the genes that have mutated affect melanin production. So they produce less melanin in their hair, in their eyes, and in their skin. That is a result of mutations. And there's lots of mutations that lead to those types of phenotypes. This, of course, is what Katie did. It's evolved to look like a dead leaf so it could avoid predation. So life evolves over time. So I always like to ask, would we recognize life if we saw it? No, I'll say probably, if we use this idea of life as doing something unique. So a question you might get on an exam would be like, would we recognize something living if we saw it on an alien planet? And if you recite what the textbook says, that's not a wrong answer, it's a B answer. If you give me more, then you get an A answer. Good? On these tests that are take home, a wrong answer does not guarantee, or a right answer does not guarantee an A, it just guarantees you won't fail. Right? So it's going to be harder. More writing, more research, but I expect you to do your research, to sit down with the notes, sit down with the lectures, and research your answers. This would be a good one. Good?
Can you give an example of how you would answer that question?
What I would do on that question is I would go through what all the slides that I talked about on what life does, and I would write that down in a couple paragraphs. I'd say, life is basics, does something. Life is an action, and I would start from there. Life uses energy to create order, right? And it does that using metabolic reactions governed by our DNA. And to ensure the continuity of life, it reproduces, and because it reproduces, it also evolves. And then that would be a good answer. And then to get an A on that, fill in the details. Good question. All right. Well, next time, we'll talk a little bit about evolution, and we'll actually start talking about A and B on Thursday. And like I said, if you feel unsafe coming, this class is pretty crowded right now. Actually, you are more than welcome to watch it on video. I'll keep live streaming and posting it for you. All right, I'll see you guys on Thursday.